Hi everyone, in this video we will continue our look into quantitative data and talk a little bit about percentiles and what are called cumulative relative frequency graphs. So it's going to be the big main ideas. We'll come back to them in the debrief as always. So let's take a look at the activity portion. We're going to go back to the height of statistics students. We have a random sample taken of 20 students, and the summary statistics are given in the box as well as the dot plot. So based on previous knowledge, why don't you try parts 1, 2, and 3, and we'll catch up to you then. So why don't you pause the video and see how you make out. All right, so now that you've had a chance to look at numbers 1, 2, and 3, let's hopefully compare your answers. For number 1, review of chapter 1. Remember, when you're describing any distribution, SOCV, shape, in this particular case, it's fairly symmetric. Introducing a word for you, bimodal, kind of has two modes, two little peaks at 66 and 70 in this particular case, but fairly symmetric is mostly your shape. Not exact, but that's where using that word fairly helps out a lot. There are outliers at both 56 and 78. Remember to do your outliers, 1.5 IQR, above and below Q1, Q3. The center is around the mean, 67.45 inches. Use units at all times. And then your variability, standard deviation, in this particular case, 4.807 inches. So on average, the data points are 4.807 inches from the mean. Next, Ariana. She is 65 inches tall. What percentage of the heights are less than or equal to 65? There are 5 people that are 65 or fewer inches tall, so that means it's 25%, 5 out of 20. And I made up a height of 72 inches to use for part B. What percent of the heights are less than or equal to that? In this particular case, 90. Now, hopefully you've also completed this table. We're just counting the dots between 56 and 60, counting the dots between 61 and 65, and then computing the relative frequency of each of those ranges so that we can talk about the cumulative relative frequency in this particular case. What does that mean? What that means is that as you look, obviously starting at 0%, right here we have 5% cumulative that are between 56 and 60. Now, cumulative, how many are at 65? Well, 20 plus 5%, 25% cumulative, which does match up with 2B here with Ariana, sit 25% right here. So there are, from the bottom of the data to 65, there are 20%, 25%. So let's keep it up. Keep adding. What's 25 plus 55? We get 80% cumulative. 95% cumulative, and you guessed it, 100% cumulative when you get to the top of this data set. Why compute cumulative relative frequencies? Well, that's another way we can display a set of data. So we're going to use that to make what's known as a cumulative relative frequency graph. So what we can do is start putting some dots. At 55, we have 0% of the data set being represented. At 60%, we have 5%. At 65%, we have represented 25% of the data set. This is estimations, by the way. At 70 inches, we have accounted for 80% of the data so far. Right, so we're looking at about 80%. We're talking like an XY thing. And then at 75, we've got 95%. And at 80, we've got 100%. And now what we can do is draw some little boxes. So now we're going to use our cumulative relative frequency to answer some questions about it. So I am about 68 inches tall. And what we can do is connect these points to estimate and interpret the percentile. So at 68, it's probably going to be about right here. So slide over to here. About what percentile? Well, it's more than halfway between 40 and 60. So I'm going to call this let's just call it the 55th percentile. What does that mean? It means that 55% of students are at or below my height. So let's estimate the 80th percentile, estimate an 80 and interpret. So here we would find 80. And so, oh yeah, we already used the 80th. We don't even need to estimate it. We already know what the 80th percentile is. We know that the 80th percentile is 70 inches and that 80% of students are at or below 70 inches. Now that we've walked through the exercise. So there were two important ideas from the learning targets at the beginning of the lesson. The first one was the percentile, and we talked about the percentile a little as we went, the percentage of values that are less than or equal to a given value. And we want to use the word at, not the word in, when describing a percentile. And one thing about percentiles is they're not an exact science. In other words, the same word percentile can be used to mean a couple of different things. Usually it's less than. Most of the time, the formal statistical definition is less than or equal, but occasionally you'll see percentiles as strictly less than. Just understand that they can be used to mean both of those things. So where did we see percentiles? Well, we saw percentiles in items 2 and 3. These were definitely percentiles. In Ariana's case, there were 5 people, 1, 2, 3, 4, 5, that were at or below her height of 65%. I'm sorry, of 65 inches. So that would be 5 out of 20 is 25%. The example of 72 inches was right here. 18 out of the 20 people sampled were at or below 72 inches. So that would represent the 90th percentile. So 72 inches is at the 90th percentile. 90th percentile. And our Ariana is at the 25th percentile. And so what you see is cumulative relative frequencies are percentiles. All right, when you see that the 70 inches right here is the 80th percentile. So when you're graphing a cumulative relative frequency graph is effectively a percentile graph. All right, so let's look at these specific things. Always start at 0 and end at 1 for cumulative relative frequency. So rather than percentages here, let's call this 1, 0.2, 0.4, 0.6, 0.8, and 1.0. So you're ending at 1, and you are beginning at 0. These numbers going up here are your percentiles. So when I looked at my height of 68, right here, I was estimating my percentile. 55% of the students are at or below my height. And following this one on the 70, that was the 70 inches was the 80th percentile, because as we had up here, 80% of the students were at or below 70 inches tall. For what it's worth, one other feature you can tell in a relative frequency, cumulative relative frequency chart, if we look at the steepness of this line, this is a very steep line between 65 and 70. Whenever you see a steep line, you can tell that it has many values, because over this 5-inch interval, the cumulative relative frequency did shoot up, and you can see that there were a lot of values in there. Most there. So that is definitely related to the steepness of the cumulative relative frequency. So at this point, now that we've debriefed, one thing I forgot, you can relate your cumulative relative frequency or your percentiles to Q1, your median, and your Q3. See if you can figure out what that said, where I'm going with this. But Q1 would be the 25th percentile, median would be the 50th percentile, and Q3, that's right, the 75th percentile. So now, take a few minutes, go over the check your understanding problems, and let me know what I can do for you. So let's take a quick moment and talk about the check your understanding problems. Just interpreting these two percentiles. 87th percentile for weight means 87% of the girls the same age have a weight that is less than or equal to her daughter's weight, where 67% of the girls have, of the same age, of course, always context whenever you're writing a sentence, have a height that is less than or equal to her daughter's height. Sorry about my handwriting there. It gets a little suspect sometimes. Next, we have this cumulative relative frequency, aka percentile graph. 30 minutes here, follow up to get about 65%. Again, this is all estimating. You're using the word about. About 65% of the calls are less than 30 minutes, which means there are 35% that are more than 30 minutes. And then your Q1 and Q3 values would be the 25th and 75th percentiles, respectively. Again, using that graph to estimate and then compute the IQR. Let me know what else I can do for you. See you next time.